Hello, welcome back to KISH-CAT classes. I hope that you have gone through the 4 videos that I made on divisibility rules. In this video, I'm going to solve CAT questions which appeared in the last 25 years. All the questions that I'm going to solve in this video are based on divisibility rules. Out of the 7 questions, I found that 5 questions are simple, straightforward questions. 2 of them requires key observation and also application of the concepts. To solve the 7 questions, first I use common sense. If at all if I have to use concept or the application of the concepts, I'm going to use very few steps to solve the question. If you want to solve all the 7 questions before watching this video, you can find the worksheet of these 7 questions in the Facebook page of KISH-CAT classes. Let's solve question number 1. A number is formed by writing first 54 natural numbers in front of each other as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 0, 1, 1, 1, 2, 1, 3. Find the remainder when this number is divided by 8. Now there are 2 steps involved in this question. The first one is we must know the number. The second one is we should have some idea about how to divide a number by 8. Now first let's focus on how to divide a number by 8. Whenever we are trying to divide a number by 8 and to find its remainder, do you remember n divided by 8 is nothing but it's 2 cube. That is like of the format 2 power x. Whenever we are dividing a number by 2 power x, the remainder depends on last x digits of n. So x digits means here x is 3, so we need to find the last 3 digits. Now how to find the last 3 digits of number is quite simple. We are writing natural numbers in front of each other, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. These are single digit numbers. So from 1 to 9, the digits are 9 digits are completed. Now since it's a 54 digits number, so we need to have 45 digits, the remaining 45 digits. Now after 9, we are going to write a 2-digit number. It means that once we have written a one number, let's say 10, we are writing 2 digits. So from 10, 11, 12, and we need to write 45 digits. However, we cannot write a complete number here at the end of it because it's a 2-digit number. Whenever we write a number, we need to write its 2 digits. Since we need to write only 45 digits, so we can write 22 numbers, 22 full numbers, and then 23rd number first digit. That is 23rd numbers 10th digit. Now 22 numbers starting from 10 obviously is quite simple. That's very easy. That is 31. From 10 to 31 we will have exactly 22 numbers. So if you want to find for this 22, you just need to add 9 plus 22, that becomes 31. Yeah. So it means that this number goes up to 1 to 31, and then we need to write the next number first digit, which is obviously 32. First digit is 3. So this number is like 1 2, it's not a comma, it's 1 2 3 4 5 and so on up to 30, 31, 32. Now we don't need 2 here. That's it. That's the number. Now to divide this number by 8, we just need to consider its last 3 digits, that is 313. So 313 by 8, what digits remainder? That must be very easy. The remainder is 1. That's it. 2 steps. 1, you should know the last 3 digits. Before finding the last 3 digits, you should know how to divide a number by 8. Yeah. Let's solve question number 2. If a number 774958A 96B is to be divided by 8 and 9. The respective values of A and B will be. It's quite a simple number. We have got a number. Instead of every single digit, some digits are ignored, some digits are given in variable format. And we need to find the numbers, and the condition given is the number is divisible by both 8 and 9. Now we know that to divide a number by 8, we need to divide the last 3 digits of the number. And the second one is we need to divide the number by 9 and divide by number. That's very simple. Sum of the digits by 9. First let's find n by 8. So here n by 8 is nothing but n by 2 cube, that is of 2 power x format. Since x is 3, so we need to consider only the last 3 digits of n. The last 3 digits of n are 96b by 8, and the remainder is 0. So here if you divide 96b by 8, the remainder must be 0. B must be either 0 or it is 1. It is 8. So here B could be 0 or 8. We cannot finalize whether it is 0 or 8. Now n divided by 9. So we need to find the remainder sum of the digits, that is 7 plus 7 plus 4 plus 9 plus 5 plus 8 plus A plus 9 plus 6 plus B by 9. So just we need to add some of the digits. This is 55 plus A plus B divided by 9. This is completely divisible by 9. Now we can directly say that it's 55 by 9 remainder plus A by 9 remainder and then B by 9 remainder. Since we have no idea about A and B, you can ignore them. So 55 by 9 remainder is 1. So 1 plus A plus B by 9, the remainder is 0. Now we have no idea about what is A, but we do have some idea about B. B can take two values. One value is 0 and the other value is 8. Let's take one value. So if B equal to 0, then it's 1 plus A plus 0 by 9, the remainder is 0. In such a case, 1 plus A. So A must be 8 here. So if B equal to 0, then A equal to 8. Let's see what happens if B equal to 8. So in such a case, it's going to be 1 plus A plus 8 divided by 9. The remainder is 0. This case, it is 9 plus A by 9, remainder 0. So A must be either 0 or 9. So if B equal to 8, A must be either 0 or 9. So the possible values for B are 0 and 8. Possible values for A are 8 if B is 0, 0 or 9 if B is 8. Let's check the answer options. First answer option, it says that A is 7, which is absolutely not possible. Second answer, it says that A is 8 and B is 0. Yes, that is possible as per this case. That's it. So it's B. Very easy, very simple. That's it. You just need to find the values for B. Yeah. Now let n be the number of different 5-digit numbers divisible by 5 with the digits 1, 2, 3, 4, 5 and 6. No digit being repeated in the numbers. What's the value of n? Now we have a 5-digit number. So that is A, B, C, D, E divided by 4 and clearly mentioned the remainder is 0. Now if a number is divided by 4 and the remainder is 0, it's very easy. If n divided by 4, if the remainder is 0, that is like n divided by 2 power x. This 2 square is of the form 2 power x. It means that the last 2 digits of the number. If the last 2 digits of the number are completely divisible by 4, then the number itself is divisible by 4. So here we just need to find the last 2 digits. The last 2 digits must be very easy, very simple. It's a 5-digit number, but we do have 6 digits. So we just need to have and these last 2 digits divided by 4, the remainder is 0. Now what we need to do is, like, we don't have any other one. We just need to go through. We just need to use the digits. Now, I suggest you to use the digits in a proper order. Let's say these are the ones. Now you need to start from 1 here and go up to 6 here. That's it. So start from 1 in the unit tens place. So tens place 1, then unit must be 2, that is divisible by 4, so 12. Then if it is 1, then 6. That's it. Now, so these are the two numbers. Now, in units place, if we have got 2, then 21, 23 is not possible. 2, 4 is possible. That's it. Now, we cannot take 2, 6. Now, units place is 3. We can say it is 31 not possible. 32 is possible. 34 is not possible. 35 is not possible. 36. Then if it's in units place, if it's going to be tens place, if it's going to be 4. 4, 1 is not possible. 4, 2 is not possible. 4, 3 is not possible. 4, 4 we cannot take because divisions are not supposed to be repeated. 4, 5 is not possible. 46 is not possible. So tens place cannot take 4. Now, what happens if tens place is taking 5? 5, 1 is not possible. 5, 2. Then it's going to be 5, 6. Let's start from 6. 61, 64 not possible. 63, then 64. So now we have got 1, 2, 3, 4, 5, 6, 7, 8. We can take 8 different numbers in the last two digits. Now, if these things can take 8 different ways, now these numbers can be filled in. That's a very simple thing. It's just a combination of numbers as well as permutation and combination. If the last two digits can be filled in 8 different ways, to fill the first 3 digits, we have got 4 digits available. So this can be filled in 4 ways. This is in 3 ways, and this in 2 ways. So that's going to be 4 into 3 into 2 into 8 different numbers. So that is 24 into 8. That's going to be 192. So 192 numbers we have got. What we have done is quite simple. If at all if a number is supposed to be divisible by 4, then the last 2 digits must be divisible by 4. We need to find the last 2 digits. To find the last 2 digits, you just need to start in a proper order. In tens place, start from 1 and then move up to 6. Once you identify a set of numbers, your task is half completed. The remaining thing is to fill the remaining digits. Remaining digits is very easy. So there are 4 numbers available and we need to use only 3 numbers. That can be done in 4 ways, 3 ways, 2 ways. That is 4 into 3 into 2 into 8. Let's solve the next question. The number of positive integers not greater than 100 which are not divisible by 2 or 3 or 5 is. So it's very simple. The number of positive integers not greater than 100 which are not divisible by 2, 3, 5. This must be very easy. I'm going to teach you 2 different ways to solve this sum. Please understand them. We have got numbers from 1 to 100. The rule is n divided by 2, 3 or 5. The remainder is not supposed to be 0. What we can simply do is, like, if at all we do have 2 methods. One method is, if the remainder is 0, then we need to eliminate that number. We have got 2 ways. One, either we can find the numbers which are not divisible by 2, 3, 5, or we can find the numbers which are divisible by 2, 3, 5 and then subtract from them. Now, I'll go with n divided by 2. The remainder is 0 method. In every 2 consecutive numbers, we have a 2 multiple. So it means that 1 in every 2 consecutive numbers is a multiple of 2 and it is divisible by 2. It means that from 1 to 100, we can find 50 numbers here. N divided by 3 remainder, if that is 0, 1 in every 3 numbers is a multiple of 3 and that is also divisible by 3. So in first 100 numbers, we have got 33. Do remember here, we have got 100 numbers. Only 33 of them are divisible by 3. But in some cases, if we are taking 100 natural numbers, not the first 100 natural numbers, if you are taking 100 natural numbers, any 100 consecutive natural numbers, we can find that there are 34 natural numbers which are divisible by 3. Here we have got 3 because the first number is not divisible by 3, second is not divisible by 3. So it starts from third one. So 1, 2, 3, it's third one. 4, 5, 6, it's the sixth one. Like this, in every 3 numbers, we have got one multiple. What is the third number of the group? Now, imagine the numbers are starting from 3, 4, 5, 6, 7, 8. It means that the first number itself is a multiple of 3. In every group, the first number itself is a multiple of 3. Let's take that there are 100 numbers. It means that we have got 33 groups. And the 34 group, we have got the first term. That's it. So it means that the numbers are like 3 to 1 or 2. These are 100 numbers. 3, 4, 5. 3 is divisible by 3. 6 is divisible by 7 and 8. And like this, the last one is 99, 100 and 101. This is the 33rd group. Now, we have got the final group, which is the 34th group. In the 34th group, the first term itself is divisible by 3. So in 33 groups, we have got 33 numbers which are completely divisible by 3, and in the 34th group, the first number itself. It means that we have got 34 numbers. So do pay a lot of attention. Whenever we are trying to divide a number, a set of numbers, and try to find that how many of them are divisibles of x or y or z, careful whether the first term, second, third, fourth, fifth, which one of the group, which term of the group is divisible by that number. Pay attention. Now, let's go back to the question. So n divided by 3 is also completed. Now n divided by 5 remainder. That's also 0. Now n divided by 5 remainder means we have got 20 numbers. So we have got 52 multiples, 33 3 multiples and 25 multiples. So we need to eliminate them because we don't need them. We need the numbers which are not divisible by these numbers. Now out of the 100 numbers, we need to subtract 50, we need to subtract 33, we need to subtract 20. So 100 minus 50 minus 33 minus 20. What is happening here? We have got 103 numbers. However, we have got only 100 natural numbers. Pay attention here. Very simple here. We haven't made any mistake here. The thing is, if there is a number, let's say we have got a number which is a multiple of 2 and which can be a multiple of 3 also. 6, let's take 6 is a multiple of 2, 6 is a multiple of 3. So it means we have counted a number 2 times. So to do it, what we need to do is like we need to take n divided by LCM of 2, 3. So that is n divided by 6 remainder. How many numbers are there? 16. So we need to add 16 here. Same is the case, n divided by LCM of 2 and 5. So it means that it's 10. So we just need to add them plus 10. Now again n LCM of, this time it is 3 and 5. That is 15. N divided by 15 remainder must be 0. How many numbers are there? 6 numbers. So we need to add them. Is that sufficient? No, it is not. What we need to do then? We just need to take LCM of 235. 235. That is n divided by 30. So that is 3. So we need to again subtract 3. Why we are doing all these things? We have added some digits. Again at the end we have subtracted the LCM of all the divisors. This is a bit confusing one. We don't get any clarity here. That's a way simple. It's very simple, but it's not giving us a full or clear view. Let me explain you in its proper way. Let's take the numbers. I'm using set theory to explain you. These are like multiples of 2 or like numbers divisible by 2 where the remainder is 0. These are numbers divisible by 3 where the remainder is 0. These are numbers divisible by 5 where the remainder is 0. Now we have got some areas where it comes under first set and it comes under second set, and there's some one area which comes under all the three sets. First, what we need to do is from 1 to 100 exactly, how many multiples are there, how many 2 multiples are there, or how many numbers are divisible by 2. That is very simple. That's 50 here. Now by 3, that's 33. By 5, that is simple, 20. Now what we need to do is, like, the first thing we need to identify how many of them are multiples of 2 and 3 and 5. That is this central part, this part. How many of them are multiples of 2, 3, 5? So you just need to take the LCM of the divisors. Here the divisors are 2, 3, 5. So the LCM of the divisors 2, 3, 5 is 30. So from 1 to 100, how many of them are 30 multiples? There are 3 here. So straightforward, 3. Now these 3 are 5 multiples, 3 multiples and 2 multiples. Now let's try to find this area. This area is exclusively multiples of only 2 and 3, but that becomes really very difficult to find only 2 and 3 multiples. So we need to find only 2, 3 multiples, but they are not supposed to be 5 multiples. Multiples of 2, 3 but not 5. That's very difficult. I suggest you to find multiples of 2, 3. That's very easy. So multiples of 2, 3 means this is n divided by 6 multiple where the remainder is 0. How many of them are there? 16. Now the 16 are multiples of 2, 3. However, 3 of them are multiples of 5 also. So you just need to eliminate the 3. Since we have already done with this 2, 3 and 5 multiple, so we just need to subtract the 2, 3, 5 multiple. That is 16 minus 3, that is going to be 13. Now the next one, we need to find this section 2, 3, 5. Look at this one. Finding multiple of 2, 5 and not the multiple of 30 is a bit challenging here. Instead of it, what you need to do is, like, this one is n divided by 10 where the remainder is 0. Find all of them. There are 10 here. Out of the 10, 3 are multiples of 5 also. So we just need to write 7 here. That's very simple. Now the final one. We have got here exactly this place. Exactly this place. This is a place only for multiples of 3 and 15 but not multiple of 30. That is really difficult. So find for all of them n divided by 15 where the remainder is 0. How many of them are there? 6. Out of the 6, 3 are multiples of 30. We just need to eliminate them. It means that this is going to be 3. So our task is completed now. Very simple. We were able to find the multiples of 2, 3, 5, multiples of 2 and 3 but not 2, 3, 5, multiples of 3, 5 but not 2, 3, 5, multiples of 2, 5 but not 2, 3, 5. That's very easy. Now, but we do know that there are 52 multiples. However, here we have got 13 plus 3, 16 plus 7, that is 23. It means the remaining 27 are only multiples of 2, or the numbers which are divisible only by 2. Now we have to find the numbers which are divisible only by 3. We know that there are 33. Out of the 33, some of them are 13 plus 3 plus 3, that is 19. 19, that means it's going to be 14. Now here we need only the multiples of 5, that's it. So the total multiples of 5 are 20. Out of them 7 plus 3 plus 3, 13. Here it's got 7 here. So once you know this information, that's very easy. Now all of them are multiples of 2 or 3 or 5 or 6, 10, 15 and 30. So we just need to eliminate all of them because these are the multiples. We want the numbers which are not divisible. Here we found the numbers which are divisible. So from first 100 natural numbers, what we need to do is like we need to subtract minus 27, minus 13, minus 3, minus 7. It's nothing but the first set, which is minus 50. The next one is like minus 14, minus 3 and minus 7. So it means it is 100 minus 50 minus 24. That is 100 minus 74, 26. So from first 100 natural numbers, 26 numbers are not divisible by 2 or 3 or 5. That's very simple. You just need to understand. Let's solve next question. That's question number 5. How many even integers where n is greater than or equal to 100 and less than or equal to 100 or divisible neither by 7 nor by 9? So we need to find even numbers, even integers n, and n is also defined, and here neither 7 nor 9. We have a range actually. Within the range, we don't need to we should not consider every number because it's clearly given that it's even integers. From 100 to 200 even integers, and they're neither divisible by 7 nor by 9. It's a simple one. It must be a simple one because we just need to find only for 7 and 9. We don't have 3 numbers here, 3 divisors. It's only 2 divisors, but it's coming with a condition. The range is given. Within the range, it's clearly defined that even numbers, even integers. First, let's take the numbers. So we have got 100 to 200. How many? These are 101 numbers. And we just need to consider only the even numbers here. Out of the 101, if there are 100 numbers, then 50 are even, 50 are odd. But we have got here 101 numbers. So it means that 51 is one set and 50 is the next set. 51 odd or even? That's what we need to find. Now, starting with even and it ended with even. And these are 101. So it means that there are 51 even numbers and 50 odd numbers. That's it. We have got 50 even and 50 odd numbers. So our task is we have got 51 numbers. Out of the 51 numbers, we need to find n divided by 7 where the remainder is not equal to 0, n divided by 9 where the remainder is not equal to 0. You can find the other way. You can find the numbers which are where the remainders are 0 and you can subtract them. Let's use the set theory. Let me draw a set. Here this n divided by 7, the remainder is 0. Here n divided by 9, the remainder is 0. This is the combination of n and combination of both divisors. The divisors are 7 and 11. So LCM of 7 and 9, not 11, 7 and 9, that is 63. So it is here n divided by 63, the remainder is 0. 3 cases. But do remember, it's only positive numbers. Now let's find how many numbers from 1 to 100 are divisible by 7. First, no need to take 51 even numbers. Just consider all the numbers, all the 101 numbers from 100 to 200. N divided by 7, the remainder is 0. Start from 100 to 200. Now, what you need to do is like n divided by 7 here. What is the first number after 100 or including 100 which is divisible by 7? 14 sevens are 98. 15 sevens are 105. So it starts from 105. That is the 15th multiple of 15th multiple. Look, the 15th multiple means it's 7 is odd number, 15 is also odd number. So 15th multiple must be an odd number. But don't take into consideration. Just go ahead. The last multiple. You just need to find the last multiple. That is 28th multiple. That is 196. So we have got 15th multiple to 28th multiple of 7 which are lying from 100 to 200. It means that there are 14 multiples. 14 multiples of 7 are there from 100 to 200. Now these are 14 multiples. Out of the 14 multiples, some of them, half of them are even multiples, half of them are odd multiples. Here these are exactly 14 multiples. Out of the 14 multiples, 7 are even and 7 are odd. Now our task is to find even. So it means that here we have got 7 numbers. So we can say directly 7 here. Next one. Let's move on, try to find here. So what is the first multiple of 9 which comes after 100 or including 100? 11 nines are 99. So that's 12 nines. That is 108. This is the 12th multiple. Now what is the last one? That is 198. That is 22nd multiple. Now these are 12 to 22nd. That is 11 multiples. Now we have got a task in hand. You just need to pay closer observation. We have got 11 multiples. Not half of them. We cannot divide 11 into 2 equal parts. One part is 6 and the other one is 7. Now look, it started from 12th multiple which is an even number. It ended with an 22nd multiple which is also an even number. So started from even and ended with even. It means out of this 11, 6 are even multiples and 5 are odd multiples. Since we need to consider only the even multiples, we just need to take 6 here. That's it. So our task is almost completed except the combination of both 7 and 6. Now here n divided by 63, the remainder is 0. How many multiples of 63 are there from 100 to 200 which are even? Now 63 is 126. That is second multiple, and the final one is 189 which is third. However, second multiple is the only one which is even, so it means that it's 1. So here this is 1. So it means that if this is 1, as a result this becomes 6, as a result this becomes 5. So total we have got 6 plus 1 plus 5, that is 12 even multiples which are divisible by 7 and 7, 9 and the combination of 7 or 9, exactly 12. Now we have got 51 numbers. Out of the 51 even numbers, we need to subtract the multiples, that is minus 6, minus 1, minus 5. This 6 is the only multiples of only 7. 1 is the multiple of 7 and 9. 5 are multiples of only 9. So that is 51 minus 12, that is 39. So 39 even numbers from 100 to 200 are not divisible neither divisible by 7 nor by 9. This is a simple set one. There are two tasks involved here. One task is to find how many even numbers are there from 100 to 200. Once that is completed, you need to do the simple reverse process, that is to find how many of them are multiples. While finding the multiples also, do pay attention. Some of the numbers can be multiples of both 7 and 9. That's it. Let's move to next question. So this is the sixth question and we have got only one more question left. Let S be the set of integers x such that this x is defined here, x is odd is given here, it's divisible by 3 but not by 7. Very good one. Very good question here. So this is a combination of previous two questions and with one more condition. That is, it must be divisible by 3 but not by 7. That's very easy. Now, x is an odd number and it's from 100 to 200. So 100 to 200, the numbers are 101 numbers. And from this 101 numbers, we just need to consider odd numbers. Simple odd numbers. Now, 100 is an even number. This is an even. 200 is also an even number. So it started from even and it ended with even. So out of the 101 numbers, 51 are even and 50 are odd. So our task is completed. So from 100 to 200, 101 numbers, out of them 50 are odd. So first two are completed. Here we have got, these are 50 numbers. The next task is to find how many of them are divisibles of 3 but not by 7. It's a simple task. You just need to draw a pie chart here, not a pie chart. Set theory, that's very easy. Now, this is n divided by 3, the remainder is 0. This is n divided by 7, the remainder is 0. And this is a combination, the LCM of divisors 3 and 7, that is 21. So it is n divided by 21, the remainder is 0. Now our task is to find divisibles of 3 but not 7. So it means that we just need to see exclusively only by 3. Not a combination of 3 and 7, not exclusive of 7. Now, let's see how many numbers. First, no need to consider odd numbers and even numbers. Let's consider all the numbers from 100 to 200, which are multiples of 3. From 100 to 200, that is n divided by 3, the remainder equal to 0. Let's see. 33 3s are 99. So 33 4s are 33, not 33. 333s are 99. Now 334s, that's the number which is coming as a 3-digit number, first 3-digit number, that is 34th multiple, which is 102. Last one is 66th multiple, which is 198. So from 34th multiple to 66th multiple of 3 or lying here, it means that these are 33 multiples total. So the 33 multiples of 3 are there between 100 and 200, including 100 and 200. Now it started with an even multiple 34 and it ended with an even multiple 66. So out of the 32, it means 17 are even multiples, 16 are odd multiples. Now our task is to find the odd multiples, because we need to find the odd numbers. So these are 16 odd. So it means this is 16. So 16 odd multiples of 3 are there between 100 and 200. Now what we need to do is, should we really find how many 7 multiples are there? No, not needed. We just need to eliminate the combination of 7 and 3 from the 60. That's a simple task. That is n divided by 21 remainder. So from 1 to 200, how many odd multiples are there of 21? So that's n divided by 21, remainder 0. So 21 fives are 105. So that is fifth multiple. Then it's up to ninth multiple. 21 nines are 189. That's ninth multiple. It means there are 5 multiples of 21 are lying from 100 to 200. It started with fifth multiple, which is an odd multiple of 21. It ended with the ninth multiple, which is also an odd multiple. So started with odd, ended with odd. So it means that 3 of them are odd and 2 are even. So since we need to consider only the odd multiples, 3, now it's going to be 3 here. That's it. 3 we need to eliminate them because we need only divisible by 3 but not by 7. So that is 16 minus 3, 13. So the answer option D is correct. What we have done is very simple here. Step by step I'll explain you in just 30 seconds. First you need to consider the numbers. The numbers are starting from 100 to 200 and odd numbers. These are 101 numbers. Out of them 51 are even and 50 are odd. So we just need to consider odd numbers. Now next one is it's divisible by 3 but not by 7. Finding the numbers which are divisible by 3 is not sufficient. We need to eliminate them. Eliminate some of them which are multiples of 7 also. So combination of 7 and 3 is 21. So we just need to find the multiples of 3 from 100 to 200, and from all of them we just need to eliminate all the even numbers, even multiples. Once the task is completed, we just need to eliminate the combination of 3 and 7, which is 21, and the LCM of 3 and 7 is 21. So we just need to eliminate the odd multiples of 21 from the set we have already found. That's it. With this we move to the final question. The number of positive integers n in the range of 12 to 40 such that the product of n minus 1, n minus 2 and so on up to 3 into 2 into 1 is not divisible by n. Now it's an integer and there is a range and a number is defined and divisible by n. So it is n minus 1, n minus 2. If we take this one, n minus 1, n minus 2 and so on up to 3, that is nothing but n minus 1 factorial. This is the number. This is our number. And when this number is divisible by n, the remainder is not equal to 0. This is the task. N minus 1 factorial by n, the remainder is not equal to 0. And the range of n is also given. It's from 12 to 40. Now how to approach this question is quite simple. Is 12 a special number? Is 40 a special number? No. 12 and 40 are any numbers. They are just random numbers. But they are given in a proper order. That's 12 to 40. Next time what happens if they give 22 to 70? What happens if they give, let's say, some other numbers? Let's say 212 to 240. That's what we need to consider. These are just some 12 to 40. That is, these are 21 numbers. Now, you have taken 21 consecutive numbers starting from 12. How can you approach this question is, look at this n minus 1 factorial by n. N could be any number. Instead of looking at 29 numbers, it would be better if you consider a duplicate one actually here. So let's take 1 to 5. What happens if it's 1 to 5? 1 to 5. N cannot be 1. So if it is n equal to 1, let's say n equal to 1. So that means if n equal to 1, that is 1 minus 1 factorial by 1. That is 0 factorial by 1. So that is by 1 by 1, the remainder is 0. This is not the task. The remainder is not supposed to be 0. So this is not possible. Let's do some experiment. N equal to 2, that is 2 minus 1 factorial by 2. That is finally it is 1 by 2. So the remainder is not equal to 0. It's valid. N equal to 3, that is 3 minus 1 factorial by 3. That is 2 factorial by 3. That is 2 by 3. The remainder is not equal to 0. This is also quite good. Now n equal to 4, that is 4 minus 1 factorial divided by 4, that is 3 factorial, that is 6 by 4, where the remainder is not equal to 0. This is also applicable. Now finally n equal to 5, where it is 5 minus 1 factorial by 5, that is 4 factorial, that is 24 by 5, the remainder is not equal to 0. This is also applicable. Now since we have considered 1 to 5, these are applicable. It does not mean that 4 numbers out of every 5 numbers are possible, because we have done it only for a set actually. Is this set good or bad? We cannot judge now. Let's do one more experiment by taking n equal to 6. If n equal to 6, then this is going to be 6 minus 1, that is 5 factorial divided by 6. Now 5 factorial is 120 by 6. Now the remainder is 0. This is not possible. N equal to 7, I'm just doing some experiment. 6 factorial by 7. 6 factorial is 720 divided by 7. The remainder is not equal to 0. This is the case. Now again, in this set, 6 is not possible, 7 is possible. If let's take n equal to 8, then it is 7 factorial by 8. 7 factorial is nothing but 0, 5040 by 8. Now the remainder is 0. This is not applicable. This is not applicable. So in first set, where we have taken from 1 to 5, except the first one, remaining 4 are possible. When we started by taking n 6 to 10, the first one is not possible, second one is possible. It seems that it is following the same trend. That is, first one not possible, the remaining. However, when we have considered 8, we have got completely a reverse one here. So it is the indicator that we are getting is absolutely confusing here. However, if you pay closer attention, 2, 3, 5, 7, these are prime numbers. 2, 3, 5, 7. However, we have got a curious case here. When n equal to 4, which is not a prime number, again we have got the remainder which is not equal to 0. What can we do here is quite simple here. Whenever we have a number n minus 1 factorial by n, where the remainder is not equal to 0, in this case the n must be a prime number. This is the only case. So fairly simple one. This is called Wilson theorem. Among the remainder theorems, we have got Wilson's theorem. This is Wilson theorem. So it means all the prime numbers, that is prime minus 1 factorial by prime number, the remainder is not equal to 0. However, we have got a case where n can take a natural number 4. Well, when we have considered only a set of numbers, we found that n equal to 4 is applicable. What happens? What can happen? What really happens if we are going ahead like up to 100 numbers, up to 200 numbers? Can we get one more number like 4? That's what you need to understand. Of course, in the examination, we cannot do all these experiments. This experiment we cannot do in the examination. Absolutely. That is why I consider that it's a very difficult one. It's not just very difficult one, it's a tricky one. Once you have no idea about what is Wilson theorem, that's it, out. Anyhow, all the prime numbers, that is prime minus 1 factorial by prime, the remainder is not equal to 0. In fact, the remainder is minus 1. And one more case is we need to add 4. Now, from 12 to 40, we need to consider all the prime numbers. From 12 to 40, prime numbers are like 12 to 13, 17, 19, 23, 29, 31 and 37. That's it, 37. So 7 prime numbers are lying from 12 to 40, where the prime number minus 1 factorial by prime, the remainder is not 0. Do remember, it's a very specific case based one. It's not at all a duplicate question. It is a very well fixed question. We cannot change the variables here. We cannot start from 12 to 40 and then we can say, okay, can we start from 1 to 28? Can we start from 1 to 29? That's what. No, you cannot. We cannot change it. Just learn it. No, cat cannot ask this question again, but they may probably ask by changing the range. That's it. What we have learned is quite simple. This is the only one which seems to be out of context. Now, if you observe this question number 1 and the question number 7, which is really confusing, that appeared in CAT 2003 leaked paper, the remaining are like 1998 to 2002. Why we don't have a question after 2003? Divisibility rules is, well, after 2003, the number of questions in the sections were very, very limited. For majority of the years, it was like 21 questions. Last year is 34, this year is 34. So if there are only limited number of questions instead of 50 questions, they need to find a lot of easy questions from many chapters, not just from numbers. Divisibility rules is just one part of numbers. We have got number geometry, algebra, arithmetic, modern math. So that's why we don't have divisibility rules. So the most difficult divisibility rules questions are also covered in this video. That's it, enough. Do watch the next one. Thank you.